In this video, we're going to learn about the sine rule. Let's start by taking a triangle, and we're going to label its sides A, B, and C. Now we're going to label the angles inside this triangle, and we're going to label each of the angles with the same letter as the side that's opposite it. So opposite the side which is labeled A, we're going to put an angle A as well, but we'll use a capital letter, so that we know that the angles are capitals and the sides are lowercase. Opposite the side B, we'll have angle B, and again we use a capital. And then opposite the side C, we have capital C for this angle. Now it turns out that if you pick any of the sides, for example A, and then we divide this by the sine of the angle opposite, so divide this by sine of A, this will give you exactly the same value as if you did this for any of the other sides. So if you took side B and divided it by sine of capital B, and this also gives you the same value as if you took side C and divided it by the sine of capital C. And this here is known as the sine rule. You can use the sine rule for any triangle, and we're going to use it now to find a missing side in this triangle here. Now, even though the sine rule has the letters A, B, and C, very rarely do you actually need all three of the letters at all. In fact, in almost all cases, you just need to use A and B. So to approach this question, we're first of all going to add some labels to the diagram. We're going to try and label lowercase a, capital A, lowercase b, and capital B. It's always good to try and make the one that you're finding the A. So since we're trying to find the side which is marked X, I'm going to make that lowercase a. If this is lowercase a, the angle opposite this must be capital A, so the 85 must be capital A. Then I would label this 11 centimeters on the right as lowercase b, and the angle opposite that one as capital B, so the 35 is capital B. Then we write out the first part of the sine rule, so A over sine A equals B over sine B. And then we're going to write this once more, but we're going to substitute in all of the numbers from the question. So if we start with lowercase a, well, that's the side we're trying to find, which is X. So let's write an X there. Then we divide this by sine of capital A, and capital A is 85, so divide by sine of 85. Then moving to the top right, we've got lowercase b, we labelled that as 11. And on the bottom, we've got sine of capital B, and capital B was 35, so sine of 35. What we have now is just an equation to solve to try and find X. On the left-hand side, it says X divide by sine of 85. So we can find X by multiplying both sides by sine of 85. If you multiply by sine 85 on the left, that will cancel the sine 85 that's already there. So on the left you just have X. And on the right hand side you've got 11 over sine 35, but we're going to multiply this by sine 85. You can type this into your calculator as it shows here, but you may also write it like this, as 11 sine 85 over sine 35. So now you go ahead and type this one into your calculator and read off the value. So for this one, we get X is equal to 19.104937. The question may give you an indication for how accurate to give your answer, often 1 decimal place or 3 significant figures. So let's round this one to 1 decimal place, and that would be 19.1, and we also need some units on there, and we can see this one was in centimeters. So 19.1 centimeters. Now let's try a second example. So in this question here, we may be asked to find the length of BC. Since there's no label here, I'm going to label on BC with an X to remind me that that's the one we're trying to find. Now, before we go ahead and label the sides and angles for this triangle, I want to point out that the corners of this triangle have actually been labelled using A, B, and C. This is very common in exam questions, since it makes it very easy for the paper to signal to you which side, angle, or point it's referring to. However, for us in this question, it's quite unhelpful, since we're actually going to label some of the angles and sides using those letters in a moment. So if you do get a question which uses this labeling technique, you may want to just cover up those or give them a quick scribble out temporarily so that you don't get confused about which letters are which. Now we can go ahead and add our labels as we did before. We're going to start with labeling lowercase a, which is the side we're trying to find, so that's where the X is. Then the angle that's opposite this one would be capital A, so that's the 80 degrees over here. Then we label the other side in the question as B, so this 30 centimeters is B, and the angle opposite that one is capital B, so that's this one here. Then we can go ahead and take the sine rule and write that out. And then we'll write it out once more, but replace all of the letters with the information we've got in the question. So instead of lowercase a, that's X, the one we're trying to find. Instead of capital A, that's 80, so we've got sine of 80. Instead of lowercase b, it's a 30. And instead of capital B, it's 93, so we've got sine of 93. Then as before, we're going to multiply both sides by sine 80 so that we get x on the left hand side. So on the left hand side we would have x, and on the right hand side we've got 30 over sine 93, but we've just multiplied this by sine 80. And as we did before, we may write this as one fraction, which is 30 sine 80 over sine 93. Type this into your calculator and you'll find that x is equal to 29.60732007. Let's round this one to one decimal place once more, so this will be 29.6, and if we add some units, which are centimeters. Now you can also use the sine rule to find missing angles in triangles. The previous two questions we used were finding missing sides. If you are finding a missing angle using the sine rule, you want to take the reciprocal of all of these fractions. So instead of a over sine A, we want sine A over A. And the same thing happens to the other fractions too. So this is the version of the formula you would use if you were trying to find a missing angle. Let's have a look at how we can do that in a question. So for this question here, you can see the angle this time is what's missing, and that's been labelled x. So we're going to start by labelling that x as A, but since it's an angle, it will be capital A. The side that's opposite this will be lowercase a. The other angle given in the question will be our capital B, so that's the 88. And the side opposite this will be the lowercase b, so 25. We then take the first part of that formula once more, and we write this out, but replace all of those letters with the information in the question. So instead of sine of capital A, that's now sine of x, the one we're trying to find. We divide this by lowercase a, so that's 18. And on the second fraction, we've got sine of capital B, so sine of 88. And this is divided by lowercase b, so that's 25. To solve this one, we're going to multiply both sides by 18. If we multiply the left side by 18, that will cancel the divide by 18, so we've just got sine of x. On the right hand side, we have sine 88 over 25, and we've just multiplied this side by 18, so multiply by 18. As in the previous two questions, you might write this as one single fraction, so 18 sine 88 over 25. Then you can type the right hand side into your calculator and this will give you a decimal. On the left hand side though, we still have sine of x, not x, but sine of x. And the right hand side, using your calculator, will give you this number here. Now this isn't the answer to the question, because this is not the value of x, but rather the value of sine of x. To find the value of x, we need to do the inverse sine of both sides. If we do the inverse sine of the left-hand side, this will give us x. And if we do the inverse sine of the right-hand side, we'll need to type this into our calculator, the inverse sine of this number here. If you do type that into your calculator, you'll find that x is equal to 46.0182803. Let's round this to one decimal place again, so that will be 46.0. And since this one's an angle, we'll put a degree sign. Let's try one more of these. So once again, we're finding an angle, so we're going to use the angle version of the sine rule formula. We're going to label the angle we're trying to find capital A, the side opposite this lowercase a, the other angle in the question capital B, and the side opposite this lowercase b. Then we take the formula and write this out once more, but replace all of the letters with the information from the question. So we've got sine of A, which is sine of x, over lowercase a, which is 5, is going to equal sine of capital B, which is sine of 110, divided by lowercase b, which is 12. We then multiply both sides by 5, so on the left-hand side this will cancel the 5, so we've got sine x, and on the right-hand side we have sine 110 over 12, and this is now multiplied by 5, which we could write as 5 sine 110 over 12. The left-hand side will remain as sine x, and we type the right-hand side into the calculator, which gives you this number here. We then use inverse sine, so x will equal the inverse sine of that number there, and using your calculator that will give you this number here. We can round that off to a suitable degree of accuracy. Let's go one decimal place again, so this one will actually round up to 23.1 degrees, and that's the answer to this question. Now we're going to look at one more example of using the sine rule to find an angle, but something very peculiar happens in this question. We're going to attempt to solve it in the way we did the other questions. So we'll begin by labeling. So the one we're trying to find is going to be capital A, the side opposite this lowercase a, the other angle capital B, and the side opposite this lowercase b. Then we take the formula and we're going to substitute the information from the question. So instead of sine of capital A, it's sine of x. Instead of lowercase a, it's 20. Instead of sine of capital B, it's sine of 33. And instead of lowercase b, it's 12. We can multiply both sides by 20 like we did before. This will give us sine of x equals sine of 33 over 12 multiplied by 20, which is 20 sine 33 over 12. Then we can type this right-hand side into the calculator, so we get sine of x equals this number here. Then we use inverse sine to work out the sides of x. So we would have x equals the inverse sine of this number, which gives you 65.2 degrees. Now at this point you might notice something a little bit off. If you look at the diagram of the triangle, this angle here doesn't look like 65.2 degrees at all. In fact, it looks obtuse, it looks greater than 90 degrees. So what's happened here? Well, if we have a look at the graph of sine of x, let's draw some axes, and we know the graph of sine of x goes between 1 and -1, and let's mark on the key points 180 and 360, and the graph of y equals sine of x would look something like this. Now when we end up with an answer of x equals 65.2 degrees, this is because if you mark on 65.2 degrees on the x-axis, go up to the graph of sine of x, and then read across, you get that value of 0.9077 and so on. Now if you look closely at the graph, there's actually a second value, another angle, that would give you this value too. So if we extend that line horizontally across, go to the sine graph, and then go down, we end up at this angle here. So the sine of this angle will also give us 0.9077 and so on. But what is this angle? Well, due to the symmetry of the sine graph, we can find this angle by subtracting the other angle, 65.2, from 180. If you do 180 minus 65.2, you get 114.8. So the sine of 65.2 and the sine of 114.8 both give you 0.9077 and so on. So in this question, it might well be the case that the actual answer is 114.8. But the question would need to give you some information to indicate which of the two angles it wanted. So for example, the question may say, given x is an obtuse angle. Now I missed that information out, obviously, because I didn't want to give away what was happening in this question. But the exam question will always give you some indication of whether that angle is obtuse or acute. This will help you choose the right one when you come to do your answer. So if the question did say, given that x is obtuse, we would finish this question by taking that angle 65.2 away from 180, getting the true answer of 114.8. But it is entirely possible the question could say, given that x is an acute angle, in which case the answer would have been the original one we found of 65.2 degrees. However, there's a new problem now. The diagram doesn't look like that's 65.2 degrees. It looks like an obtuse angle. So what's happening here? Well, it turns out there are two possible ways of drawing this triangle. What we can do is move this 12 centimeters across like this and extend that bottom line, and we haven't actually changed any of the information of this triangle at all. The sides are still the same length, the 33 degrees is the same, the only thing that changed is that angle x. So if this were the case, the diagram should actually really look like this, in which case the original answer would have been 65.2 degrees. This particular situation has a special name. We call it the ambiguous case, because unless you're given some further information, you can't tell which of the two angles is the correct one. So rest assured, in your exam question, if this does happen, you will be given some information. For example, it will tell you whether the angle is acute or obtuse.